better to apply as a transfer.
Okay, that can actually be back.
Because you apply, but you don't actually get into the engineering program until after your first 2 years.
Ah, there, got it. Just had to warm up. Just had to warm up a little bit. Look at that. Yeah? Just gotta be gentle with her.
College Park, you only get something like a couple of 35. Like, they're pretty up there.
Trying to get a cow to give birth, you can't just run up there and start taking the cow out. You gotta let the cow warm up to you a little bit, or she's gonna be mad at you. Okay, fine. If you want to milk a cow.
Have you ever done that?
Milk a cow?
Have you ever done that?
What?
Giving birth to a cow?
No, I've never given birth to a cow before.
No, like, have you ever delivered a, like, not.
Even though I lived on a farm when I grew up, I never had to deliver a cow. My father always took care of it.
Where
Did you
at?
watch him do it?
No.
So
He
where
didn't have
at?
me do anything on the farm. He wanted me to do
He
something
might be
else.
bored on the phone, but he wasn't that bored. He wasn't that bored.
He wanted me to
So
do
you never
something more
moved
than
to
a
I would have
cow
wanted to
man.
watch
Where
that.
at?
Like into a bucket?
Really?
I got better things to do than watch someone
Miller-
give birth to a cow.
What?
Someone?
And then I'm just
Some
like,
cow
I
gets
used
birth
to
to a cow.
watch, like, where is it, like, on TV, on that, the health channel. And then, like, as a senior, when I had my internship at the hospital, I saw, like, a C-section. It was awesome.
That's
It was awesome.
I was there
Not
when
awesome
I
for
had
that
my
person.
mother.
It wasn't awesome for that person.
She said it was fine.
Alright, swimming pool is 50 meters long and 20 meters wide. There's a picture for you. Its depth decreases linearly along the length from 9 meters to 1 meter. It is initially empty and it starts to fill at a rate of 1 meter cube per minute. And you wonder how fast the water level is rising. 810 minutes after the filling begins. How long will it take to fill the pool? Woo! That is a rough problem.
Yeah, dude.
Yeah? You have to describe for me the volume of the pool. How is the volume of pool dependent upon its height is what you wanna know. Why do you wanna know that? Because they have given you the problem, they've given you dV/dt. You know the rate at which the volume of the pool is changing. It's the same as the flow into the pool. Although here it comes out of one little spout, and so it appears like it's a great flow. When it hits the bottom of the pool and spreads out, the pool does not rise very quickly, correct? It doesn't rise very quickly. But it's certainly being filled at the exact same rate at which the substance comes out of the spout, the pipe. Okay? So you know dV/dt in the problem. So what you want to relate V to is some function of h. Because that's what you're trying to figure out. You're trying to find out dH/dt, right? dV/dt is known, and dH/dt is your question. Make sense so far? So we're how to think about the problem? Think about what they've given you, think about what you're looking for, and relate the two. Then take a derivative. So we need to find the volume in terms of height. So now you just got to figure out the volume in terms of height from all those dimensions there.
Wait, how do you know dV/dt? How do you know that?
That's the inflow.
It
Oh,
says
1 meter
that
cube
1
per
meter.
minute.
Yeah.
Okay.
Okay. Yeah, that's what it is. That's how fast the volume is changing for the pool. That doesn't tell you how fast the height is changing, though.
So how would you be able to find that height? Because I mean, you could take the volume by like using the triangle as a base and using the 20 meters as the height, right?
Okay, so let's try to draw some of that picture.
So is it like dH/dt at at something equals 90 feet, 90 minutes, or no, that's
There's that wedge of water taken out of context, yeah? We know that this is 1. We know that this is 9. The rest of it, here goes 20 here. And that's a 50. Okay, there's all the information. this thing is changing. So, what's that extra 1 foot? Bothering me. There. So that is going to be how the pool would fill. The pool would fill up until here, and it would be in the form of a triangular wedge until it goes past this. Then it's a triangular wedge with a rectangular wedge on top of it, right? Very thin rectangular wedge. So you cannot use the numbers initially because you don't know at what height you are. So what you have to do in this case is make up some arbitrary location here, right? You're going to call that h, okay? Here's your arbitrary height. You're going to pick an arbitrary location within this triangle to make another triangle. You're going to use similar triangles. This is our first similar triangle related race problem. Similar triangle related race problems. So, let's see what we got here. So what we got here now? Line 1, 50, 20, fine. So you have a pair of similar right triangles. This one, and we got this one. Okay? Both of the triangular wedges, whether it is the large upper one, which is fixed, or the bottom one, which is changing with time, they both have the same rectangular slab this direction. Okay? So the focus is on the similar triangles here on this side which is closest to you. Okay? Now, what is the height of the fixed triangular wedge? What is this height right here? 8. It is 8. Okay? That is the important height, not the 9. So, color or something. So this height here is 8. Because the outermost is 9, and the start of the rectangular slab is a 1. So you have a height of 8 here, fixed, for that rectangular slab. So now you've got your smaller triangular slab down here, which is a function of time. Now the height is changing as you fill up with water, right? So now you can relate these two triangles to each other. That's what you need to do. Relate the two triangles.
Isn't the height of that pool 9?
The height is, but the height of the triangular portion of the pool is only 8. And we're trying to use a similar triangle construction here to figure out the answer.
Why is it 8? How do you know?
Because that's a 1 over there. That part is 1.
Oh, okay.
Okay. So you got these two right triangles, one inside the other, so they're similar. Now you need just to relate them together, relate the sides together. Can you do that? Can you do that? You relate the sides to each other. They're similar to your right triangles. What's this length here? What's the dash line? 50. You know that's a 50. What's this hypotenuse here? Can you figure that out? Square root of